Good afternoon, Web Summit. Hope you've had a nice lunch. Hope you're not feeling too sleepy. It's getting late in the afternoon. We're going to talk about scale today. This talk is going to be slightly different to some of the other talks if you've been to them here in the developer workshop. This talk is really subtitled the 21 times that Sean's been set on fire by CEOs and other people at companies. It's going to be a personal history of things that I've kind of broken along in my career, customers who I've helped who have had issues at scale, and what we did to fix those. Just like every true crime detective TV show, some names have been changed so that we don't frame the innocent and out the guilty. So I'm going to talk through today my history and also some of the common problems that you face as a startup when you're scaling. So my startup experience, I went to a company in the UK called Betfair. At the time, they were still pretty small. We were doing about £4,000 a second of transactions. We had 1 million customers after being around for about 5 years. And at the time, there was a company called Sun. So Sun is now part of Oracle, and they were the hardware place that you bought your servers off. And the funny thing about what we were doing was we were doing exchange-style trading. And exchange-style trading back in the early 2000s wasn't really mature. There wasn't really high-frequency trading shops doing it in the city, in the financial district. And so what happened, is we also had a death clock. And so my life was run by this death clock. And what the death clock was we were growing so fast on a hockey stick style growth that we couldn't buy any bigger hardware in the world to run our startup. There were bigger servers, but we couldn't use them because as you bought bigger servers, CPU can only address so much memory. And as you got bigger servers, that means that the memory moved further away from the CPU. And we couldn't handle the time it took to traverse that path. And so we used to have a death clock on the wall, which was like, this is how many days you will survive until we just fall off the end of the hardware and we can't take any more transactions. And so to solve that problem, we reached out to Sun, and Sun was also the inventor of Java. And there was this young guy back then who had just written a book called How to Scale Java on the Internet. And that young guy was Adrian Cockcroft. And he became famous from some streaming website later on. But he actually was quite famous back then for being one of the few people who understood how to scale websites of the internet age before the FANG had come around and solved all those problems. The other problem that we had was we had one of the hottest, the 5 hottest Oracle databases in the world. And so we couldn't buy any bigger database hardware to run our database. So everywhere we went, we were basically chased by, you need to write new software that is better than what we currently have and write it from scratch because there wasn't open source libraries all over the place that we could use. So we did manage to fix that problem, and we went from 77,000 transactions per second on our database to 1,100 transactions per second after Adrian helped us and we rewrote a bunch of our software. So that was my original startup experience. And I thought, this is going to be awesome. There's going to be all these huge startups around with massive scale, and I'm going to be doing things bigger than all the hardware that exists. So I moved back to my home country, and I started working for another company. And this company had also got onto the fact that there was this group of customers who really wanted to do financial transactions through APIs. And this was a problem I was working on in about 2010. And this line actually represents the number of seconds it took for us to process 2,000 transactions. And you'll see right at the end of the graph, there's a huge dip. Now, unfortunately for me, in about May, when I didn't really understand the kind of technology that we were using, I spent about $300,000 of someone else's money buying new hardware, thinking that I would speed up this particular time. So that actually went in May there, and you'll see it went completely flat and then didn't change at all. So I wasted $300,000 of someone's money. Not recommended for your career. And then I actually figured out that we could change the program, much like I had in my other startup, to solve that problem, and we got it down to 2 seconds. So as you're taking investor money and as you're thinking about what you're going to use for cloud infrastructure or whether you're bootstrapping it yourself, remember that hardware doesn't always solve the problem. It's most likely going to be an application error. The other problem with this system I was working on was written in Fortran. So Fortran, the version we were using, was cut in 1981, so just after I was born, and was very good at maths and very bad at connecting to anything on the internet. So that's how I started in scaling. And then we moved into the cloud era. So what do these three pictures have in common? Does everyone know who the person on the right is? So this is Steve Irwin. So I started working at a company that ran the three biggest news sites in Australia. And at the time, we'd just had a huge outage. And the outage had happened because Michael Jackson had died. And everyone on the internet went refresh, 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 want to read that blog. And it basically broke the internet in the country. And my boss at the time got dragged in front of a committee, and they basically asked about, how are you going to stop this from happening again? We don't want it to happen again. And we spent a bunch of money, and we told them it would never happen again. And then Steve Irwin went for a swim, had an unfortunate encounter with a stingray, and passed away. And at the time, no one really in Australia knew who Steve Irwin was. He wasn't actually on the TV in Australia, but he was very famous in the US and in Europe. And so the issue that we had was that the news sites in Australia, where we had 20 million people, were built for 1 million people maybe coming online at once. But all the US news sites decided to link the local Australian ones. So instead of 20 million people, we had 200 million people try and hit our news sites. And that didn't end up very well for us. The third one in the middle is actually a picture from the Sydney siege. So that's the third time that our company broke the internet, basically, and most of the sites in Australia that weren't the Facebook and the FANGs actually went down. So there's probably like a common cause in all of these things here, which is me. So this is probably where I advise you never to hire me, because it seems like I go to places and then the entire internet breaks around me, or we have kind of outages. So that gave me a very good feeling about how to scale things and basically what not to do. And the problem was that Australia is an island, and it's not very well connected to the rest of the world. There's just basically water around us. And we had pretty much 2 tin cans and a piece of string as our internet. There was only one way into the US, and back then it was very, very small. So we just choked the entire bandwidth of a country from these news stories. We actually had an instance after that where we were doing pretty well. We were doing about 500,000 requests a second, which back in the pre-FANG days was pretty damn good. We're scaling very well. We thought we'd handled it. We thought we'd solved all these problems, and I thought, yeah, I'm not going to bring the internet down this time. But unfortunately, we had people work for us, and they were working in marketing. And marketing always want to update things, and they always want to do news stories, and they want to put new images on. And this particular marketing person had decided that what we wanted to do was put up a whole new version of the page to handle one of these huge internet spikes. And so what he did was he cleared the cache on our CDN. The CDN that basically had everything stored in it that the entire country and the entire people who were linked in from the UK and America was hitting, which meant we had no cache, which meant that 1.5 million people just decided to punch our servers in the face as hard as they could with no cache in the middle. And so you never clear the cache. That's my first lesson. Anytime that anything goes wrong, anytime that you're scaling, anytime that someone says, hey, I just did a show hacker news post and pasted our startup on front page, it's going to be awesome. Never go in and think, what we need to do now is update our page so people keep reading it. Never clear the cache. Luckily, there was a duck that I found that fixed this meme up for me, seeing as we're streaming it online. And so this is actually should be a 429, but I like the 431 meme picture better, which is basically request too large. So we fell over again because with no cache, then the cache fell over because we couldn't fill it up, and we basically had about a 12-hour outage. So this is my history. And Australia was a small country, and so I thought that I should go and break bigger things around the world. So I moved to Southeast Asia a couple of years ago, and in Southeast Asia, we have 650 million people. We have 7 unicorns. I have one customer who has about 90 million users, and another one of my customers who I helped scale who went from 0 to 5 million users in about 5 months. And so these are some of the lessons that I learned helping those startups scale, and also getting out of the $20 million people trap that I was in. So we're at Web Summit. Everything is about stages here. You've got alphas, you've got betas, you've got the growth stage. So I thought I'd make it a bit more local. So this is Mariana. She's just finished her STEM degree. Mariana is also one of the top 5 names to name your babies in Portugal in 2017 if you're an expecting parent. It's giving you some extra info. And she really likes chorizo. And she really likes, and she wants to build a startup instead of going to work for someone else around chorizo. And she goes and she builds it for a while, and she tries to get some money, and she comes to places like this and she pitches, and she's not really getting anywhere. But in the meantime, she's also heard about cool technologies like blockchain. So decides she's going to put her chorizo tweeting app on the blockchain. So she does this, and of course then every VC known to man runs to her and gives her a bag of cash, because now she's got some blockchain in her app. And so the VC's happy. He runs back to San Francisco, high-fiving, bro, I've got decentralized Twitter for chorizo, and our startup lady, Mariana, is happy. So she's in the alpha stage. She doesn't really have much tech, and she really needs to decide on what she wants to do. So most of the startups I talk to, and I've just done mentor hours, they literally go to this website, start looking down a whole bunch of history lists and searching it, and go, okay, the top 3 things that are on Hacker News are what I'm going to build my website for because it's cool. This is not how you want to choose the technology for your startup. But that's actually what a lot of people do. Oh, I think I walked out of range. There we go. So this is the most common stacks as the internet tells us. There's a few issues with the way that these are actually rated, because the internet, in the way that people rate them, doesn't really include mobile, because most of the internet rating sites about who's using what in servers don't actually scrape mobile, they only scrape the servers. So who in here is using one of these stacks or a variation with something like React or Vue in front? Excellent. So 80% of the internet, back only about 10 years ago, was LAMP. Who's got LAMP in here? Yeah. It's quick, it's dirty, it works. You can get to about 10,000 users, no problem. You can get to your second round of funding before you run out of LAMP. And actually, most of the internet is built on this. This is how the internet used to work. I've got my browser, I've got my web, I've got my application servers, and I've got my database. And actually, most startups who start out, they actually get one server and just ram all of LAMP onto it, which is always fun when you're the next employee who has to come and pull it back apart. And so we map our technologies onto the internet and how it kind of works. And this is really what most of us are doing in startups. We're building this type of stuff. The only thing our VC and our money guy cares about is that he wants his features, and we don't really care that much about the infrastructure till it starts falling over. And if you want some LAMP hosting, you can go and do a search. There's 2.5 million entries. You can go and find yourself a cheap VPS host somewhere and ram your LAMP onto it. And you'll get started, and you'll get about your first 10,000 customers before things start to go too bad. But there is a really good piece on Medium about innovation coupons. When you are starting a startup from scratch and you've got the idea, you should not be out bootstrapping completely new technologies that are bleeding edge, because you'll spend all of your time trying to do library dependencies and writing extra libraries and not actually writing features for your startup. So there was a really good blog post about you get 2 innovation coupons. So you can use Postgres and you can use PHP, but then you can't use like Meteor or like Mongo or something else that's newer. And the idea is that you don't take too much new tech into your stack as you're building out your startup. I wish I could remember the guy's name. I actually searched for it before I come up, but I can't. Hopefully he might watch the VOD and remind me about his post, and I'll actually be able to accredit him properly to it. But it's one advice that I give all the startups I talk to down in Southeast Asia when they come to me and talk about the crazy tech that they're going to use that's basically bleeding edge, that's about a year away from 1.0. The next thing is you don't want to be Netflix. So Adrian saved me before, but you don't want to be Netflix. If you go and look on Netflix's repos on GitHub, whoa. They have over 50 different products that they have built to bootstrap infrastructure, to monitor infrastructure, to write open source, to do load balancing. That is not what you want to do as a startup. You don't want to be Netflix. You don't want to spend hundreds of hours building infrastructure code. You want to build your actual startup. So don't learn from Netflix. Don't learn from the big FANG. Go and build something that's very small that gets your product to market quicker. So don't spend your time on the tech. Get it out to your customers. So problem number one, when you go back to your individual lamp stack or your spa, you'll probably encounter this. This is one of my favorite problems to encounter. It happens to startups of all sizes. I had a startup who'd taken almost $1 billion of funding and nearly had a 24-hour outage because no one in the entire company understood what Linux file descriptors were. They're a file that basically gets picked up every time you run something like an Apache web server or Nginx. And every time you have a user come in and take a connection, it takes one of the files. If you're using something open source like Ubuntu, out of the box you get 1024. So it doesn't matter what bigger box you buy, you only get 1024, and that's as big as you're going to scale, even if you've got a $10,000 server. So I've got a config up on my GitHub for Nginx. It's from about 3 years ago, but it will basically get you to about 500,000 connections on Nginx and on Ubuntu. You can go and rip it down. So we are in the alpha stage. We've got past our 10,000 hurdle. We now know what file descriptors are, so you're not going to have to ring me up, and I'm not going to have to come and explain them to you. So we should move on, and we should get to our beta stage of our startup. So Mariana is now in full startup mode. She's got headphones on and a laptop. She's ready to go. The trouble is her bag of cash is starting to run out. She's got quite a few users now. She's building features. And so she's whacked some AI into the app for her Chorizo tweeting app. And now she can do chorizo, no chorizo, and everyone's happy. So the VCs are super stoked about this because now they've got a decentralized Twitter for chorizo that also has AI built into it. So they give her another bag of cash so that she can bootstrap a beta. And she goes on now. She's starting to get a whole bunch of other developers and employees on board. And she's starting to hit some other scale issues. So about this time, she goes and Googles around. And people start talking about this guy, Sam Newman. So I was super lucky to be sitting with Sam Newman a long time ago when things like LXC were just getting talked about. Docker wasn't called Docker. And we were talking about scaling and services and service-oriented architecture. And he was actually writing a book. So about 2 years later, he came out with this. And this is pretty much the Bible for most people who want to go and look at how to build microservices in bigger companies. And at this stage in your startup, you might start thinking about, why is my monolith performing so poorly? Now I've got all these developers on board and they can't change anything because it takes so long to test everything, and every time someone changes something, it breaks and I have to get out of bed. So you really want to take your monolith or your APIs that you're now sparring, and you want to move them over to something like microservices. And actually what you want to do is a step before that. You actually want to do this bit first, which is the services. You don't want to go, hey, I'm going to go microservices and split everything into 50 little honeycomb things that you have to manage, because then you actually have to hire 5 DevOps people just to manage your microservices that you didn't need before. So you need to think really carefully about your domains and what the services are. Is it payments? Is it identity and login? Is it something that you can split out that's easy in your business? And then you can go and think about microservices. So if we look at the anatomy of a microservice, we've got our data store. Whoa. We have our application logic. We have our API. And it's all happily bundled in our little dotted circle there. And we want to avoid software coupling. So one pattern of the LAMP era and everything doing server-side was that we used to have one massive database that everything plugged into, which was my world when I started, and we had this Oracle database, which was one of the top 5 performing in the world. In microservices, you want to split the data domains out and make sure that there's no coupling. And you want to split them out into domains that make sense. So you split out payments, you split out things like market services, and you split out into smaller and smaller components so that you can maintain. But as a startup, you only do this as you hire the people to maintain them. You don't just split them out to give yourself operational complexity. There's lots and lots of discussions I have with customers who go, but I don't understand where to split my monolith into. Where do I build this service? So the kind of way to think about it, and what Martin Fowler talks about, is basically you don't want the Swiss Army knife. You want to use the Unix philosophy. So do one thing and do it well. One tool for the job. And once you've done a little bit of that, you'll have a new problem: eventual consistency and distributed transactions. And that will cause what's going on over here, which is a common occurrence in my life with small children, which is cascading failures. And one way to protect against that, so if you think about one of the patterns that we use to stop this, which is circuit breaker. So if you're a startup and you need to take someone's money, you're most likely not going to be the person who takes the credit card. You will outsource it to a Stripe or another payments provider. And what you need to build is start building some mechanisms like circuit breakers, like exponential backoff, so that when your service, when the third-party service starts to break, your service fails gracefully. You might not take payments, but you can still see your account balance. You pull back from the third-party service so that when it starts up, you don't ram it with thousands of transactions that basically get you blacklisted on their website. And so there's a link up there on Martin Fowler's blog, and that goes into this actual circuit breaker pattern. He's actually got an example in Ruby. You might have to write your own in a real language. Okay, so we've solved our file descriptors. We now know about circuit breakers. We can start to look at some patterns. We now have a few microservices going on. We've run out of cache again, unfortunately. Our AI and our blockchain couldn't quite get us far enough, so we've come back to pitch at Web Summit again. And so now there's only one thing really left for us in the buzzwords to get some more cash out of the VCs. So we are going to quantum compute our tweet chorizo app here. It's the only way really to get to the growth stage. And so Mariana's happy, she's got a whole team, and she's starting to have some real issues, because as you build really fast and you build your product, you don't really think about things like this conversation, which is, I now have a whole team who owns an API, and maybe that API is the most important thing in my business. And now I have all these other people who want to plug into it. And so you need to have a very specific, idiomatic way to say service A can talk to service B. And you need to understand that relationship. You need to be able to put in things like TPS limits in a centralized service, so that service A and the market service, for instance, can't talk to the payment service at more than 15 TPS. And you need a way to enforce that. And so you need to start building common libraries that do things like access, authentication, so that these kind of problems don't start to throttle you when you start hitting that 20 developers, 25 developers. This is about when that starts to affect my customers. Standardized logging. So now you're in the distributed world. Someone says, hey, you lost my payment. You're like, I don't know, went through 5 of my services. Everyone's got their own logging scheme. Someone's using Go, someone's using some other language. You don't really know how to find it. And so you need to start implementing things like UIDs and finding out what is actually happening in your service. This is also going to be the only way in the future that you'll be able to measure business metrics. So you might roll out Kafka or some other event source. And now you're going to start rolling all these up to say the average payment takes X amount of seconds, the average tweet takes X amount of seconds. And so you need to start measuring your business stats. The other thing you need to learn to do is degrade gracefully. So when something breaks, and it always will as you start to go distributed, how do I make sure that my website can still do things, my mobile app can still do things? I can still read the timeline, but I can't place any new tweets. I can't register a credit card, but I can make a payment if I already have one. You need to break down your domain so that things fail without causing the cascading failure issue. And the last thing is to cache locally. So I was recently working with a customer, and that customer is quite a scale. So they had a Redis cluster that had 256 gig of memory that was completely full, and they used to store their session ID in there. And another service was hitting that session ID 20,000 times a second, and the service team who owned it didn't even know that someone was reading it 20,000 times a second. So when there was a network blip and this other service couldn't read it 20,000 times a second, and they started basically hammering the Redis cluster with a bad lookup, it actually destroyed the Redis cluster for all the other 150 services that they had in this startup because they didn't know that someone was reading something at 20,000 times a second. Now, session ID is a bit hard because it does need to be centralized because you need to know if someone's logged in. But for most of your other services, do centralized caching. Don't build massive Elasticsearch clusters and massive Elastic Redis clusters. It's exactly the same anti-pattern as building the one database to rule them all and piling everything into it. So this goes back to what I was talking about a few slides ago, which is understand who's actually talking to your service. You own the data. You shouldn't have random rogue people hammering your data at that kind of frequency. So I asked before about what technology stacks you're using. Who's currently building a startup and has faced some of the problems I'm talking about? Who's thinking about building a startup and now knows what file descriptors are that didn't know before? Okay. Now, you could go to the world of serverless. Someone else is managing the server, so you'd never have to worry about file descriptors, but you will have to worry about things like service meshes. So one pattern that is not in here, and it talks a little bit about that service A to service B. This will be an emerging pattern, things like Istio, load balancers like Envoy. There's going to become a time when it's going to be very hard, or it's going to be much easier for you to do multiple services. Right now, doing multiple services in a small startup is really difficult. You will end up with DevOps people. You'll end up with that one dev who's the infra guy, because he knows a bit of Python scripting. And so he's spending all his time building these things. So if you are starting to have issues where you're going to multiple services, go and look up Service Mesh. There's some really good ones that are funded by the Cloud Native Compute Foundation. Tomorrow's talk that I'm doing, which is around transaction management, so how to take other people's money, what happens if you lose other people's money, how not to lose other people's money. It's quite important for startups. Turns out people don't like you losing their money. That whole talk and the demo I built is basically 88% CNCF native. So fostered by an open group. It's got different things in there like event sourcing, like service meshes, some of the container orchestration. And you can look at those kind of mature patterns. They're also the ones that big companies and the FANG are actually using internally in production. So they're upstreaming all their changes back. So my comment before about don't be the Netflix, if you start using those tools once they're in 1.0 status, other people are going to do all the changes for you. They're going to build all the tools. They're going to build all the SDKs and the language that you want to use. So you should just be able to focus on actually building your business applications. Okay. I'll take some questions now before I finish out. Does anyone have any questions after what I've asked? No questions. Is everyone too afraid to ask anything? Has anyone not had an outage in the last few weeks? So after this, there is my colleague Adrian Hornsby, and he is going to talk about going multi-region in the cloud. He's going to start talking about things like distributed load balancing, how to split sessions over multiple regions, how to back up databases across different regions. Now, if you're not in the cloud or you're still starting out, most of that talk is still relevant to you because it applies to whether you have AZ1 and AZ2, Data Center 1 and Data Center 2. At some point when your startup gets big enough, you'll need more than one thing. You can't survive with the lamp box under the desk for your whole time. Yes? Yeah?
How brave should you be with microservices? How maybe you haven't figured out fully some of the domains you dive in.
Yep.
Go build one or wait to completely have it figured out?
Okay, so the question is, how brave should you be with microservices? When do you know when to peel the first one out? What should you do? So Martin Fowler, who kind of made this stuff famous, I guess. It was always been around as service-oriented architecture. The reason no one uses SOA anymore is actually because SOA got kind of stolen by the vendors and got replaced with enterprise service buses. So if you've ever worked in a big company that has this enterprise service bus that you have to go through to make any changes, that's what kind of SOA became. So on the microservices side, Martin says that you should always start with a monolith. You don't actually understand your domain problems as a startup when you start. You should never peel it out or start with microservices because there's a massive operational overhead of distributing things. The monolith can talk internally very well. But at some stage you will reach scale where the monolith won't scale anymore. More likely though, because you can buy a box these days with 128 CPUs, you'll find an issue where people can't update fast enough. So you'll have a product team who wants to go really fast and one who wants to go really slow. Or you'll have technology on the front end that wants to change really fast and an API that can't change because you've already got users using it. And so you'll generally peel them out based on that and the actual team structure than you will on, I need to move it out because I want to own it or because it's got performance issues. You won't really hit the performance issues till you get much bigger. Okay. Yeah, so a gentleman just asked about building large or multi-node Elasticsearch clusters. So Elasticsearch and Lucene are awesome technologies. You should use them. They are awesome for full text search. What you shouldn't do is build a ginormous one that all your other 10 services actually plug into. You should split it out and do small ones just like you're doing for the rest of the microservice. The problem with that is if your business gets very used to, like if you already have one, and I see this quite a bit, where the business gets used to being able to full text search everything that goes into this one cluster and they basically build it, and they make it their big data and analytics store. So now your Elasticsearch, which is supposed to be your operational data store, becomes the thing the business uses to figure out what's actually going on in your business. So that's one thing that you want to avoid. You don't really want any operational calls going into your live databases. All right. So building out like this is a journey. This is a picture from 2008 from Werner. Vogel's our CTO. This is the last time we've been able to map it. We actually had some interns come in and try and map our microservices in Amazon again recently, but we basically couldn't do it because of the split network. So this is from 2008 with the amount of microservices that Amazon's built. We actually have SOA. We don't really call it microservices. And a lot of the principles that I just talked about, what our principal engineers at Amazon actually do. So we have something called principal engineer review. If you're a startup who's getting to 10, 15 developers, it's highly advisable that you hire someone like a principal engineer, and they'll be able to review things like you're building a brand new service and you've gone and done an awesome implementation of binary tree search, except everyone uses hash maps now, and by the way, Redis has kind of already solved that problem with queues, so like leave me alone and go and do that. And so you won't waste a whole bunch of time re-engineering the world, which is what a lot of startups get stuck into and grinding out of. So these challenges are what you're going to face. As soon as you start splitting anything out of the monolith, you'll have eventual consistency. You won't really know what data is at state. You start becoming a little bit like a larger company where you probably won't know how much money you've made until the end of the day because you won't be able to grab it in real time. And so that's why things like eventing and service discovery become really important. Service discovery is still not native in a lot of services in the cloud and in open source. And so you're still manually building files with IPs in them and containers and other style things. The other thing is coordination. So what happens when you start building multiple microservices that need to roll back a transaction, and I'll talk about this tomorrow. 3 microservices might have actually talked to that transaction. The third one fails. You need to roll it back between number 2 and number 1 as well. And most microservices don't handle that coordination. Most startups don't have the sophistication in their software to actually roll that back. And so what some of my startups do is actually just double charge the customer and then reimburse them the next day, which is not a good thing. But you will have to think about how do you actually do this kind of distributed rollback and transaction locking. What some customers do is build an observer that observes and manages those transactions, which basically becomes a monolith and a complete breaking of the loose coupling, because that one service now manages all the transactions in the entire business, and if it falls over, then no one does transactions again. So it's actually a reasonably hard problem to solve at scale. I'll leave you with this one last thing. It's very important for startups. Being woken up at 3 a.m. every night is a high motivator for writing good quality code. As you go through startup journey, you'll remember this. As your customers ring you, things break, pages go off. Hopefully you don't have to learn by taking the internet out in countries on the way like I did. So enjoy your startup journey. Remember, if we haven't scanned you, that we are giving away $200 in AWS credits so that you can go and test out some of these technologies. The talk after me with Adrian Hornsby is going to talk about multi-region load balancing from the infrastructure side more than the app side like I was talking about. It'll be a good add-on to this talk to talk about how you do things like auto-scaling, how you do things like database synchronization. So I'm Sean Ray. That was Scaling in the Cloud. Thank you very much.